In this lesson, we're going to begin the study of complex numbers. All of our math that we've studied to this point, and I'm not talking about what you might have studied outside of this class, but in this class, everything we've done has dealt with the real numbers. And the real numbers include the fractions, the decimals, the square roots that are irrational, negatives, positives. All of those have been real numbers. Now we're about to enter into, first it's called the imaginary numbers, and then we'll move on and talk about, so what does it mean to talk about complex numbers? I'm going to go back and say something that I've probably said before. The square root of 25 is 5 because 5 squared equals 25. We had a discussion in maybe the very first lesson that you can't take the square root of a negative number, because when you try to come up with an answer, every time you square it, like I did the 5, you get a positive 1. Well, mathematicians said that's true. There is no real number that you can square it and it becomes negative 1. So we will create a new number, and the new number is called I. And it's usually written kind of as an italicized I. And the square root of negative 1 will be called I, and the rest of this definition, I squared equals negative 1. Now that's a definition. We don't have to prove it. It is simply written in mathematics as a true statement. So now that we have involved this new number, now we can take square roots of negative. I is called a pure imaginary number. There are numbers that have really two components to them. There are numbers that look like 5 plus 3i. This is a complex number. It has a real part, which would be 5, and it has an imaginary part, which is called 3i. And this is a complex number. In the study of complex numbers, you find that complex numbers can all be written in the form some real part plus or minus some imaginary part. Now, even real numbers fit in this category. So it's like the complex numbers are the big, giant, overshadowing group, and within it are those that are combined, like 3 plus 5i. There are those that are real, that are like 3, and if you wonder where the rest of it is, it must be plus 0i. And then there are those that are pure imaginary. Whoops. And those might be like 5i, and what's the real part? It would be 0. These are all types of imaginary numbers. Those that are combined, that have both the real part and an imaginary part that are non-zero. The real numbers are a subset of the complex numbers. They simply don't have an imaginary piece. It's 0. The pure imaginary numbers don't have a real piece, or you could say its real part is 0. So when we talk about complex numbers, we are talking about involving the concept of a brand new number I. This is important, and I hope you will remember this. The square root of negative 1 is I. Also, it is equally important to remember that I squared is negative 1. Now, let's just look at some complex numbers. All right, the first problem, it says express this in terms of I. Now, here's what I suggest that you do. If you have a square root and the radicand is negative, factor out a -1 under a radical and write the rest of it under another radical. This part, the square root of -1, is I. The square root of 9, since that's a perfect square, is 3. That becomes 3i, where I write the I behind the 3. So, in the first lesson of this unit, we would have had to say this does not have a real solution. And it still doesn't. But now we know about numbers that are not real, the imaginary numbers. So we can explore square roots of negatives. This one says to simplify using I notation as needed. All right, I know that the first thing I'm going to do, because I see that negative, is put the square root of -1 times the square root of 216. Now, I don't know if 216 has a perfect square factor, but because it's even, on my calculator, I'm going to see if 4 goes into it. So 216 divided by 4, it does. It goes in there 54 times. I'm going to box that in because it's a perfect square. Does 4 go into this? No, it doesn't. But I do know a perfect square that goes in there. 9 goes in there. It's 9 times 6. That's a perfect square. Remember that the product of perfect squares is a perfect square. That means that 216 is 36 times 6. So this is the square root of -1 times, and I will break 216, perfect square, 36, non-perfect leftover factor, 6. Square root of -1 is I. Square root of 36 is 6. And I don't know what this is. Now, the commutative property of multiplication says I can write these in any order I want. I want the 6 first. I want the I to come after it, but I want it to come before the radical. The radical always needs to be last, and the I comes in front of it, and if there is a numerical coefficient, it comes in front of that. All right, so that's how you simplify. We would not have had any trouble, just the square root of 216. The square root of 216 would have been 6 times the square root of 6. But the square root of -216 is 6i square root of 6. You'll always, when you have a negative under the square root, you will have an I in its simplified form. All right, let's look at this one. I see a negative, so I know that's the square root of -1 times the square root of 17. Well, the square root of -1 is I. Can I simplify the square root of 17? And the answer is no, because it's a prime number, no factoring. So there we go. That's all I can do with it. It is I times the square root of 17. Number 4 looks familiar. I think it is a repeated problem. You'll probably not have repeated in your homework, but it's going to be the square root of -1 times the square root of 9, which is I times 3, and we would write that as 3i. The square root of -28. It's the square root of -1 times. Can you, well, I'll just put 28 for right now. Can you simplify the square root of 28? I'll keep this. What is a perfect square factor that goes into 28? How about 4? It's 4 times 7. So now let's take our square roots. The square root of -1 is I. The square root of 4 is 2. And I'll leave the square root of 7. I will rewrite the order 2i square root of 7. I think I have one more. All right. 2 times the square root of negative 144. That is 2 times the square root of negative 1 times the square root of 44. Can I factor the square root of 44? Well, yes, I can. I have 2 times the square root of negative 1 times 44 can be broken into perfect square 4 times 11, and 11 can't be broken any further, so what do I have? Bring down the 2. The square root of negative 1 is I. The square root of 4 is 2, and I'll keep the square root of 11. Let's multiply the 2's. 4i square root of 11. So now I hope you feel a little more comfortable simplifying square roots that have negative signs, because now we've entered into the complex numbers.